Hello students and welcome back to my channel. So let us continue with the same chapter, acids, bases and salt. So through all the experiments that were conducted previously and the activities, you can clearly observe that all the acids, they behave similarly. They show similar properties. Acids, when they react with the metal, they give out hydrogen. So let us conduct an experiment to understand whether all acids have hydrogen, but whether all substances that have hydrogen, whether they are acids. Take a beaker and connect two iron nails to a battery of 6 volt connected to a bulb and a switch in the entire circuit. These iron nails are attached to a cork, rubber cork, and into a beaker. So in this beaker you add dilute hydrochloric acid. You will observe in this experiment that the bulb starts glowing when the switch is turned on. When the circuit is complete, the bulb will start glowing. This proves that hydrochloric acid, it conducts electricity. So all acids, when they are in a aqueous form, when they are dissolved in water, they dissociate into their respective ions. For example, hydrochloric acid, it contains H plus and Cl minus ions. So H plus is a cation and Cl minus is a anion. So these ions are responsible for the current flow in a system. So when this experiment, can you substitute dilute hydrochloric acid with glucose and alcohol solution, you will observe that the bulb will not glow. So this shows that alcohol and glucose, they do not conduct electricity. That is because they do not get dissociated, they do not get ionized, and ions are responsible for the flow of current. It's the same thing is also with bases. Bases also they get dissociated. For example, NaOH, sodium hydroxide, they split into Na plus and OH minus ions. These ions are responsible for the flow of current. Acids and bases, they conduct this electricity, which in other words they are called electrolytes. Electrolytes are that allow the flow of current through them. So when they are dissolved in solution, they get ionized into their respective ions. And for you all to understand this concept more in detail, this is how electrolytes work. So there are weak and strong electrolytes. The acid or the base that they dissociate completely, ionize completely, they are called strong electrolytes or strong bases, and the ones that dissociate weakly, not completely, they are called weak electrolytes. And this is a very important factor also to define how strong or weak an electrolyte is. So it can be clearly understood by this activity that all acids, they have H plus ions, they have hydrogen present in them, but all compounds that have hydrogen in them are not necessarily acids. Like glucose and alcohol, they have hydrogen present in them, but they don't exhibit the properties of an acid. It has been mentioned clearly in this experiment. Now let us understand what happens to acids and bases in water solution. Let us understand this with an experiment. Take a test tube and add around 1 gram of solid sodium chloride into this test tube. To this test tube, you start adding concentrated sulfuric acid to this and close it with this cork. Attach a delivery tube. You will will observe that the reaction taking place and it gives a gas. So this gas is tested with litmus paper, dry litmus paper and moist litmus paper. So you will observe that the litmus paper, it will change its color only when it is in the moist state. So this proves it that hydrochloric gas, when it is in contact with water, that is the litmus paper, moist litmus paper, it gives hydronium ion and Cl minus, H3O plus Cl minus. So this hydronium, these both are ions that are formed when HCl, it comes in contact with water. So this is the cation and this is the anion. So in acids when they come in contact with water, that is the time they form ions, like I have mentioned earlier. So H plus ion, H plus, which is a cation, and Cl minus anion, these ions are responsible for the charge of electric current, which we have studied in our previous activity. So hydronium ion is formed when H ion, H plus cation, it combines with water. This is hydronium ion. So this experiment proves it that for HCl to form its ions, it has to come in contact with water. So here it is not in a single state but combined in the hydronium ion. It's not in the single hydrogen ion form. So this similar thing happens with bases. Sodium hydroxide, which is a base, when it comes in contact with water, it dissociates into sodium, Na ion and OH ion. So this is hydroxide ion and hydrogen ion. So acids and bases, when they come in contact with water only, that is the time they form their respective ions, cations and anions. So this similar process happens with various bases, and the bases which are soluble in water, they are called alkalis. Now let us understand what happens when water is mixed with acid or base. You must have come across when you are working in the lab that your lab attender or your teacher always gives you a warning that when you want to use acid or you want to dilute it. So normally acids, they come when you have to perform a certain experiment, you have to use a certain normality of acid. So to get that normality, you have to dilute it. So suppose 0.25 normality or 0.5 normality of acid, you have to dilute it. So there's always a caution given when you're new in the lab that you always add acid to water for dilution. You don't add water to acid, because when you add water to concentrated acid, it starts spurting out, and this could be very dangerous. It could even hit your eye or burn, or even the beaker could crack. So this is very dangerous. So always a caution is given that you have to dilute this by adding an acid to water. So this is how you dilute it. So let us understand this with an experiment. You take a beaker and add around 10 ml of water to it. To this, drop by drop, add sulfuric acid to it. So you can soon observe when you add drop by drop and continuously keep on stirring this mixture, that this beaker starts getting warmer and starts getting heated up. So this is because it's an exothermic reaction. when an acid is diluted, it's added to water, the ions get decreased, they get diluted. So this reaction taking place is an exothermic reaction. So when water is added to acid, the reaction is so exothermic that it could even break the beaker. So mixing this acid or bases with water to decrease its ion concentration is called dilution, and this mixture, the solution, is called as diluted solution. So how can you say a particular substance is acidic or basic? It's very simple. It's just a value. It's a value between 0 to 14. It's a number. So when a substance has its pH below 7, from 0 to 7, then it is acidic in nature. And when its pH is above 7 to 14 on the scale, then it is basic in nature. So the pH value, it defines whether a substance is acidic or basic in nature. It's very simple. It's a scale from 0 to 14. Number 7 defines where the substance is neutral. Below 7, it's acidic. Above 7 to 14, it's basic in nature. So pH, P, it stands for potence in German, which is the meaning is power of H plus ion. So H plus ion defines whether a substance is acidic or basic in nature. When it has more H plus ions, it is more acidic in nature, and when it has less H plus ions, cations, it is basic in nature. It is being stated over here, more number increase in cations, H plus ions, it is acidic in nature, and decrease in H plus, it is basic in nature. When there is decrease in hydrogen ion, there is increase in hydroxyl ion, and when there is increase in hydrogen ion, then there is decrease in hydroxyl ion. This balance between hydrogen and hydroxyl ions, H, OH, this defines whether a substance is more acidic or more basic. When there is more hydrogen ions, it's more acidic in nature, and when there is more hydroxyl ions, it is more basic in nature. There are indicators which define whether a substance is acidic or basic in nature. There is artificial and natural indicators. Artificial are methyl orange, phenolphthalein indicator, and natural are red cabbage leaves, turmeric, litmus is an extract from a plant. Also certain petals of flowers, they are also used as indicators. There is pH paper, which you dip it into a solution and it changes its color. So the color defines whether the substance is acidic or nature, and its value, it gives the pH value. But to be more accurate and more precise, in labs there are also available pH meters which give almost accurate results. So by now you all must have understood or at least got a brief idea as to what are acids and bases. So for you all to understand pH more clearly, I will state some examples of our day-to-day life. So from the time you get up, you brush your teeth, you use a toothpaste. You know that this toothpaste has a specific pH value. The reason behind it is when food particles are left behind in your mouth after you eat lunch or dinner, these food particles, the bacteria present in your mouth, it degrades sugar and these food particles and it produces acids. When acids are produced in your mouth and the pH reduces below 5.5, this decays your teeth. The teeth enamel is the hardest substance in your body, and this is made of calcium phosphate. So this, when it is acidic in nature, your mouth below 5.5, this corrodes your teeth, and that's how your teeth decays. That's how you must be wondering why we always tell children that not to eat too many sweets, or always keep brushing your teeth, because your teeth will get decayed. So this is the reason. The toothpaste plays a very important role to protect your teeth, and also mouthwash and many other remedies. So always remember to avoid your teeth from decaying. The pH is very important. It should be below 5. When it is above below 5.5, that's where your teeth start decaying. So keep brushing your teeth regularly to avoid this. You must have heard of acid rains. Normally they say that the first rainfall is acidic. So acid rains are when the pH reduces below 5.6. These acid rains are very dangerous because they reduce the pH of the soil, the water that they flow into, which enters the seas and the ocean. They reduce the pH of that, and that in return, which is interconnected, it disturbs the balance of the environment. Like for crops to grow, and certain plants, they have a particular pH value, and when it becomes too acidic or too basic, these crops and plants, it's not fit for agriculture. So even the soil has to have a particular pH for good cultivation. The fish, to survive in the ocean, in the sea, it requires a particular pH value, and these acidic rains, they disturb this pH value, and that is how a lot of destruction takes place. Acid rains, they also cause corrosion to ion component structures. That's how you can understand that pH is so interconnected and so important. How important is pH? Have you all anytime been bitten by a bee? So you must be wondering why I am asking this question. If not a bee, at least you must have been bitten at least once in your life by an ant. So when you are bitten by an ant, it soon gives you a pain and irritation, and you start itching that particular part, and it becomes reddish in color, and it gives you an allergy. So this reason is plants, many plants, certain plants and animals, they have a defense mechanism. So this, like honeybee, it leaves a acid when it stings, and that's how you get that irritation and pain. So the best remedy is to use something which is basic in nature and then subside this pain and irritation. Also certain plants, the leaves of certain plants, when you touch it, it soon starts irritating your skin and starts scratching. This is all examples of acids and bases. So by now you should at least be knowing few names of certain acids and bases. I will mention a few. Tamarind that you eat is actually tartaric acid, and milk, sour milk, which is curds, it is lactic acid. Orange that you eat and lemon is citric acid. And you know what is vinegar? It's acetic acid. Oxalic acid is tomato. So you must be so surprised that so many things you eat and consume and you didn't even know that what acids they are made out of. So by now this is your homework, that understand and learn all the things that you consume and use in your day-to-day life. Understand it, name which acids you must be knowing, and also anything that you use, just check it on the packet, the pH value and which acid it is made out of. Like sauces or jam or whatever, to preserve it, preservatives which are used, you must be observing on the label which all acids are being present or the ingredients that are present. So keep doing this at home, it's a good homework for you all. I'll see you all in my next class, and there we will study about salts.